We are starting Chapter 5, which is about algebraic expressions and properties. This is 5.1, about algebraic expressions. So let's start by defining an algebraic expression. And that is an expression that may contain numbers, operations, and one or more variables. So an expression is like the first part of an equation without the equal sign. So we have 3 plus x. There's no equals, so we have an expression here. I mentioned variable. So a variable is a symbol that represents one or more numbers, usually a letter. So here my variable is x. And I have terms, and those are numbers or variables by itself, or a product of numbers and variables. Terms are separated by addition or subtraction. Terms are not separated by multiplication or division. So if I have 3 plus x plus 2y, my terms are 3x and 2y. 2y is its own term because they're multiplied. So now let's look at this. I have 5x plus 3. X, we know about variables. 5x is a term. 3 is a constant. And a constant is a number without a variable. It's just a plain old number. It could be a fraction, it could be a decimal. There's no variables on it. Now 5 is a coefficient. And a coefficient is the number in front of a variable that is multiplied here. So I have 5 times x. I don't write this multiplication symbol, they're just right next to each other, and so I know that they are multiplied. We are going to identify the terms, coefficients, constants, and variables in each of these expressions. So in 2x plus 7, my terms are 2x and 7. Coefficient is 2. Constant is 7. And my variable is x. Just looking at what is each part of this and what is it in this one. In 1/2 y plus 6, my terms are 1/2 y and 6. Coefficient is a half, so it can be a fraction. My constant is 6. And let's look here. So I have 3x squared plus y plus 4. My terms are 3x squared, y and 4. Coefficients are 3 and 1. My constant is 4. And my variables are x and y. If a variable is by itself, there's no numbers with it, it has a coefficient of 1. So that's why this 1 in front of the y is here. It's a little invisible 1, but it's there. Now let's rewrite using exponents. So I have 2 times x times x times x. My x is being repeated, so I'm going to rewrite that with exponents. And my exponent shows how many times it is repeated. So I have 2 times x cubed. I don't have to write this times. I can just put them right next to each other. So I have 2x cubed. For 7 times 2 times y, I can have my y squared, because I have 2 of them, and I can simplify 7 times 2, and then I simplify further, and I get 14y squared. Let's rewrite this one with exponents. 3 times x times y times y. Y is being repeated, so it gets an exponent. And then I can't combine x's and y's. They're different variables, they mean different numbers. So I just write them all together, 3xy squared. And they are all being multiplied. A little bit different. Let's evaluate when x equals 5. So in my expression, x plus 6, I'm going to make x equal 5, and I'm going to find my number answer. Evaluate means to find the number answer. So I plug in 5 for x. And 5 plus 6 is 11. What if I have 3 plus x plus 10? Again, I'm going to plug in 5 for x, and I have 3 plus 5 plus 10, which is 18. What if y is 12? I will have 2y, so I have 2 times 12, and we know that when they are right next to each other, it means to multiply. So 2 times 12 is 24. What about when k equals 3? So I have 4k plus 2, plug in 3 for k, and you have 4 times 3 plus 2. Order of operations, 12 plus 2 is 14. I could also have two different variables, meaning two different numbers. So in x plus y, if x is 2 and y is 3, I have 2 plus 3, and my answer is 5. In xy, this means x times y. So I have 2 times 3, and my answer is 6. Here's a little bit more complicated. 2x plus y minus 1. Still, x is 2 and y is 3. So 2 times 2 plus 3 minus 1. Following order of operations, 4 plus 3 minus 1. 4 plus 3 is 7, minus 1 is 6.